Assalamualaikum. My name is Syakirah Binti Amir and I am from class F4 AS12001_8 and my matrix number is 2020@15936. I am doing a chemistry video presentation. I am doing photochemical smoke. Introduction. Introduction to the photochemical smoke. An important contributor to air quality is photochemical smoke. Initially, the word smoke was coined as a mixture of smoke and fog and was traditionally used to describe air pollution caused by the burning of coal that emitted smoke and sulfur dioxide. London was particularly well known for this form of air pollution in the 19th and 20th centuries. As a cause of over 4,000 deaths in London, the Great Smoke of 1952 was reported. Although air pollution caused by coal burning has become less widespread, air quality continues to be affected by the combustion of fossil fuels. Source of photochemical smoke. During the 1950s, the components of photochemical smoke were identified. This reaction of solar radiation with airborne contaminants such as nitrogen oxides and volatile organic compounds produces this form of air pollution. Via vehicle pollution and manufacturing processes, these chemicals, which are called primary pollutants, are also released in the atmosphere. Ultraviolet light can separate nitrogen dioxide into nitric oxide and monoatomic oxygen. Ozone can then combine with oxygen gas to create this monoatomic oxygen. Primary contaminants are labeled things like ozone, aldehydes and peroxyacetyl nitrates. Photochemical smoke shapes the combination of these main and secondary contaminants. Photochemical smoke is a source of air pollution due to the reaction of solar radiation to mixtures of nitrogen oxides and volatile organic compounds from airborne hydrocarbons. In modern industrialization, smoke is a byproduct. In large cities that have a humid, sunny and dry climate, this is more of a concern because of manufacturing and the number of motor vehicles. Chemical processes. Oxidation. Oxidizing smoke is also known as photochemical smoke. There are many ways to describe oxidation reactions. Oxidation is an oxygen gain in terms of oxygen transfer. It is also possible to describe oxidation as hydrogen reduction. In electron transfer terms, the most critical use of oxidation is defined. Oxidation can be defined as an increase in the number or loss of electrons in oxidation. The distribution of charge reflects oxidation numbers. In other words, if the compound was composed of ions, oxidation results indicate the charge of the atom. Reduction. Reduction may involve hydrogen gain or oxygen loss. Reduction may correspond to electron intake, which results in a decrease in the number of oxidations. Formation of photochemical smoke. Phase 1. People will start driving in the morning, consuming nitrogen or oxidizing it. The nitrogen oxidation number is 0. The nitrogen in nitrogen oxide has received an oxidation state of positive 2. Phase 2. In another oxidation process, nitrogen oxide joins with oxygen after several hours. The oxidation state of nitrogen in the nitrogen oxide is positive 2. In nitrogen dioxide, the nitrogen does have an oxidation state of positive 4. Phase 3. The accumulation of light energy by nitrogen dioxide results in a reduction of the reaction. The nitrogen in nitrogen dioxide does have an oxidation state at positive 4, and the nitrogen in nitrogen oxide is positive 2. Phase 4. Atomic oxygen mixes with oxygen gas in the sunlight to generate ozone gas. Phase 5. The reaction is dependent on the temperature and sunlight. Alternative reactions. Instead of ozone, nitrogen oxide and nitrogen dioxide may also interact to hydrocarbons to generate other volatile compounds identified as PAND, peroxyacetyl nitrate. Brown photochemical smoke seen on hot, sunny days shapes the aggregation of ozone and volatile organic compounds together with the energy from the sun. Summary. In conclusion, photochemical smoke production depends on solar radiation, hydrocarbon and nitrogen oxide emissions at atmospheric stability for increasing concentration. Commuter traffic releases nitrogen oxide and hydrocarbons early in morning. At the same time, since the sunlight will break it down to nitrogen oxide and oxygen, nitrogen dioxide can drop too. To form ozone, the oxygen is then free to react with dioxygen. Soon afterwards, by high noon, oxidized hydrocarbons react with nitrogen oxide to raise nitrogen dioxide. This response makes nitrogen oxide to decline and ozone to develop, creating a maximum of ozone at noon and minimal of nitrogen oxide. References. These are 4 references I am using to completing this video presentation of chemistry about photochemical smoke. Thank you.